Hello, welcome to the September 2021 edition of No Diagnostic Required, a monthly look at what's happening in the C++ community, with me, Phil Nash, and my co-host, Anastasia Kazakova. How are you doing this month, Anastasia?
Hey, doing good. Actually, finally and luckily back to swimming, which means I'm back to listening to CppCast. So yeah, hi Jason and Rob. And I had some strange feeling recently while I was swimming, and I was listening to 2 episodes of CppCast, and one actually included our JetBrains ads, which felt kind of creepy. But the other one was, with that guy who just recently was working like in JetBrains for a while and then moved to SonarSource. I don't know. Do you know who it was?
No, I have no idea. I'll have to catch up on that one.
Yeah, actually, that was a great episode with you, Phil, and I really enjoyed that. And I just noticed also that Rob and Jason were constantly asking you about the CPP chat restart. I'm not sure. Maybe they're unhappy with no diagnostic required. I don't know what's the reason, but they were asking for maybe a couple of times during the episode about like when you're gonna have a new episode of CPP Chat. So I don't know. Do you know right now when is the next episode of CPP Chat?
Well, you would think that I would, but I don't offhand. But probably not until after CppCon at this point. So a few weeks out. But we do definitely plan to get back onto that.
Okay.
But at least they finally acknowledged that we are doing no diagnostic required to a strict monthly schedule. So
yeah, that's true. True.
So how do you listen to podcasts while you're swimming?
Actually, that's a funny thing. I have my iPod, a very like kind of old version, the standard shuffle iPod, but it's patched by the company, which I guess they do not exist right now. I bought it maybe 5 or 6 years ago. It was called Waterfree or something like that. And they were just patching the regular iPods to make them waterproof. So that's actually cool because that's a real true iPod shuffle, which lasts for years, I guess, in terms of the battery life. And it's very small, and so I can just swim with it and like listen to the episodes, which I just put there to the playlist. So yeah, but the funny thing is that I'm usually shuffling the episodes, so the order in which I'm listening to CppCast is sometimes kind of random, which is also sometimes very weird and creepy. But yeah, I really like the setup. It works nicely.
I actually listen to CppCast in a semi-random order as well.
Randomized.
Okay. So that's an interesting concept, which is a nice segue into our first topic, which is to do with concepts and enable if and benchmarking them. So, want to tell us about this one?
Yeah, that's actually a very interesting benchmark and a very interesting article by Arthur. So the benchmarking performed there was actually performed in order to answer a question: which constraints methodology is faster, like SVNI using std enable if, or C++20 constraints using the requires keyword. And I have to say in advance, there is no clear winner in all compilers, which was a little bit of surprise to me, but it was very interesting indeed to dive into this. So results actually differ from one compiler to another, and also they depend on the generator selected to produce the translation units for the tests. And you can find how the generator in the test look like in the article. So there are these code pieces, and there are several options tested. So the first option is actually coming like several options for SVNI std enable if in the tests are coming from the libc++ approach that actually changed back in 2019 when the standard enable if usages were updated to a slightly different technique. And so the new technique actually includes less instantiations and more type aliases being used. And another variation in this generator is coming from like different approaches in the generator itself, like either using the extra value parameter or extra type parameter. So these code pieces, they actually produce different results. So you can see like several lines here, and these are these different generators. And as I said, the tested options, they're all described in the blog post, and they all produce different results on different compilers, and that's a very interesting like output. So like on Clang, the requires approach is significantly worse in all the tests. That's kind of more or less clear. On GCC, the requires approach shows kind of average results, and the extra value parameter approach always showed the best results. On Microsoft's compiler, the requires approach becomes worse with the number of overloads in the test growing. I guess the maximum is up to 400 or something like that. And the shape of the curve is different from the others, which is completely different from like other two compilers. So yeah, all these changes and how Ardor is actually changing the generator, the test itself, and how the results differ from from the best to the worst. That's kind of a little bit surprising to me. So there is an attempt to explain what's going on with the Microsoft compiler there, but still there are the biggest surprise probably is that many different results with the different shapes, with the different winners, and when one winner might become a complete loser in the on the same compiler with just changing how the things are working. So yeah. If you want the details, just dive into the article. It's like two parts of the articles. There is one part with some initial tests done by Arthur, and then there was some comments from the audience. Actually, there is a huge thread under the post with some comments from the community. And so he actually updated the generator and made a few other tests with he changed the approach when he was initially explicitly specializing the function, and then he changed to template argument deduction approach, which is this second column. So yeah, and these are the results. So if you're looking at the pictures in the digest or on YouTube, so there is this nice pictures, and you can find them definitely in the blog posts. So yeah, this is the benchmark. So what do you think about it, Phil? How do you feel about these different results?
Well, first of all, it's very thorough set of benchmarks. The level of detail that Arthur goes into to get all the different variations, not just across compilers, but techniques as well, which does show you just how much really goes into this. And I think that's really what's at the heart of this. On the surface, you'd think that a feature like requires that's specifically designed for this purpose, you would expect should actually have better compile times than the complete abuse of the language that enableif makes use of. But of course, we've been using enableif for many years now, and compiler optimizers have been optimizing that particular usage for many years, whereas required we've only had for months really. So give it time. I think as we start to use concepts more and more, the compilers will optimize for it more, and we should actually start to see a clear winner, is my hope at least, because otherwise we're definitely doing something wrong.
Yeah, I hope so indeed, because I don't think there is any case where the requires is a kind of clear winner here. There is no such case for now in the test and the benchmark. So, but yeah, let's hope for the best.
Yeah. Okay, well, the next story from C++ Stories is about returning things. What do you want to tell us about this one?
Yeah, that's actually a guest blog post on C++ Stories blog. So it's not originally from Bartek. And the author of this blog post is sharing kind of practical example from the robotics area, which is interesting by its own. So the whole example. And the author explores the solutions to kind of typical problem in this area, how to handle requests which can bring data or no data at all. And he actually trying to do his best to avoid a test for no data after calling a decoding function each time, because it just looks very, I would say, not nice in the code. Let's call it this way. So the solutions constructed and compared in the article are this listed in the title, like stud any, stud optional, and stud variant. So yeah, 3 obvious solutions which are coming to your mind when you're thinking about how to handle this kind of return thing. So std any can contain any value of any type without any specification of the type. And this looks quite flexible, I would say, like you can put anything and we're happy with it. But it quickly turned out in the article that you can't avoid specifying a type because you need it for return that data function. Std variant is something like the union, and std optional is probably the closest to the problem specification itself, like holds a value or no value at all. So all these 3 options are actually with the code examples are presented in the article, so you can look at them. But it's interesting that in the end, they're discussing that there is also a possible implementation that doesn't use inheritance, because you might remember we discussed that in the previous episodes of No Diagnostic Required, this article by Arthur about like how bad it is actually to inherit from the std library types. And so there is also an implementation which is trying to avoid this pattern. And it's interesting that they are also discussing some proposals which are not yet in the language, but also might help to address this kind of task in the future. So yeah, like several options available, and you can select whichever you prefer. And kind of very practical example, which is always good if you want to, learn how to apply it to the real life. So yeah, just go through the post if you're interested in how to do that in C++. Any thoughts on that, Phil?
Yeah, I definitely file this under one of those. It's not so much about the destination as the journey. And I expect many people would be like me on first reading this. Your first thought is, why not just use std optional? That's exactly what the purpose is for. And that was sort of what the ultimate conclusion was, but in a very roundabout way. And he does go into why, he was misled early on. He couldn't get optional to work the way he expected, and so he explored the other possibilities. And as a result, we do get to just have a look at all the different trade-offs that these different types give us, and why, okay, they weren't the best solution for this particular case, but there's other reasons why you might use them in other cases. And yeah, eventually he does actually come back round to using std optional, albeit still wrapping in his own type, first through inheritance and then through composition. And I would have gone straight for composition myself, but again, it's interesting to see other ways of doing things. And actually, if you read the comments at the end, there were quite a few people saying, just use std optional. And
yeah,
he was defending wrapping it in his own type as an abstraction. So I wouldn't do that, but there are some valid reasons to want to do that, because you do protect yourself from a particular implementation. You might want to swap it out for something else at another time. You may even want to do it to preserve ABI, which seems to be the popular topic at the moment. But yeah, it's just it was interesting for the story, hence on C++ stories, rather than necessarily, this is how you do it.
Yeah, that's true.
You can draw your own conclusions, I think.
Yeah. And actually, there is another article in the list I would like to discuss today, which is also about kind of, this story. And not the result, is about like forcing the deep const-ness by Revson. So in his blog, he wrote an article about const qualification exception to the template deduction and how to force this const-ness in this case. So so the problem is that this function template that gets a pointer to a constant object of type T can actually be instantiated with a pointer to a mutable object. And kind of, oops, that's okay, it works. And so Barry's kind of, as I said, that's again an article about the journey. So he's exploring the ways to address this constant, to fix it, to force it actually. And so there are a few ways to force it in this situation, and a little bit tricky because he tries to fulfill the requirement that he doesn't want just to, require the incoming type to be constant, but to force it to become constant. And that's why the concepts approach, for example, doesn't work for him. He's also using this span and some code manually converting to const. And It has its, again, success and failures in these cases. There are some discussions about these implementations, and I guess the most successful one is with this manual conversion. But it seems to be kind of successful, but looks weird. And so the discussion then again goes to some possible solutions that are not in the language itself right now. So they're just discussed some further proposals like deduction guides for function templates and some like concepts which are not C++20 concepts, which can alter the interfaces. And they're actually just a nice way of doing exactly what is implemented in this, when he's manually converting to const, this altering the interfaces is just a nicer way of doing these things. So again, this is kind of this article about the journey, how to do that, which options we have for now and which we might have in the future, and why it's better. For example, these kind of different concepts to just show you how to do the things which are actually correct and right, but just a little bit nicer. That's about this article, I guess. Anything you would like to add?
I had a couple of thoughts. First one was, I like the way he takes this. I like the way he takes this from first principles by first showing that actually this is a bit of an exception in the implicit conversions model, where when you have a pointer to a non-const object, you can implicitly convert that to a pointer to a const object. That doesn't apply once you start wrapping that in other types, and that's where the problem comes from when you introduce a template type like span that has like reference semantics. You expect it to behave like a reference or a pointer, but it doesn't by default, and that's where we want to try and get that exception back. And there's not an easy way in the language to achieve that today, and that's obviously what the article is then about, the different trade-offs. And then you mentioned non-C++20 concepts. So the original concept that was going to be going into C++ OX, which became C++ 11. The actual feature that he was talking about, something called concept maps. So quite a big part of the original concepts that didn't actually make it through to what we got in C++20, unfortunately. That's a very powerful feature. And you can see why it had to be taken out, just to make sure that we actually get concepts at all. But it's a shame that nobody really seems to be talking about, maybe we should actually get that back. And even Barry in the article, although he talks about it, says it'd be a great solution in this case, and I agree. He then says, well, maybe we'll get that, but don't hold your breath. So I think there is this implicit understanding that it's just a bit too far for what we want in the language. And I think that'll be a shame, because where I've seen it in other languages, and it comes in different forms, both statically and dynamically, it always seems to be a real sort of game changer in terms of what you can actually do, because it allows you to adapt your interface in a very non-intrusive way to conform to other interfaces effectively. And whether that interface is, to say, it's a static or a dynamic interface, depends on the actual language feature. In this case, it would be a static one. And I think that's a real shame, because the way you compose types and functionality together is a really important part of software development. And any feature that makes that more powerful, I think, is a good thing. So maybe this will be enough to start the discussion again, but we'll see.
Yeah, I totally agree. Like this kind of concept of the more powerful concept, which is like this transformation possibilities. It might be very interesting, but it's indeed looking quite dangerous. I mean, like it should take some time to get it into the language. So it's good we have at least the concepts we have. Yeah. Because like, look what's happening with some other really big things, like, contracts, for example. So maybe it's a good start, but would be interesting to look forward into these like more powerful concepts.
Yeah, excellent. Of course, the one thing that's often holding us back is ABI, and we have a long story about that one.
Yeah, that's a really long story. I mean, like long story. Thanks to John Hindmead about this very long article dedicated actually to C and C++ ABI. I mean, like, it's a very hot topic, a very popular topic today, and maybe some people are even a little bit tired of it. But I would say that if you're into these discussions, or you're at least, try to follow them, it's good for you to, take some time, maybe take an evening and read through the article. It truly worth it, because what I like about it the most, I won't tell you in any details, brief or short, the whole article here, because it's really a long read. But I would really encourage you to read it through, because for me, it's maybe the best collection of ABI failures in C and C++ you ever met these days in the community. I mean, like, usually when people are talking about the ABI, they're like coming with one or two examples saying like, hey, look, here we failed with this new shiny feature in the standard because of the ABI failures, or here we like fail somewhere in practice because of the ABI, or here like something happened because of the ABI. But this is really a collection of all these stories in one place. I mean, he's discussing like how changing the copy constructor changes how it's called, with some examples in assembly, and you can actually look at how it works. So he's talking about the C, not just the C++. Like, what's the problem of having two identical C functions where one takes long and one takes like int 128t, like problems with nested functions. Why are we stuck with like pure performing std regex? Like, remember the Hannah's talk on regex library and like all her benchmarking? Why designers of different libraries like POSIX and Ethernet protocols libraries are reserving bits, for nothing, for at least just in case, we all do that in the networking. What was the problem with stud format with locale issues, and the Microsoft story behind the no unique address? And I think we'll be back to it a little bit later today. So all these stories are actually collected with all the details, like what actually happened, why was the change, what was the ABI break, and like in case with C functions, even with this kind of with the constructors, or with all this assembly code, so you can actually look at how it all works. So all the stories are collected in this very long blog post. So after reading through it, you will know what's actually all these people around you are currently discussing for a year or maybe more already. So there is lots of maybe frustration shared in the end and through the whole blog post, but the more I was reading through these stories, the more I actually got to this point of frustration. Because when you kind of meet one story, that's fine. When you meet two, you're like started to thinking that something is going wrong. When you have like 10 stories like that, you start to kind of understand what's actually going on there in the modern language evolution and why we're actually discussing the ABI. So if you would like just to understand why we all are so crazy about it right now, just read through it. That's a very interesting, but yeah, kind of long read. I don't know, Phil, did you manage to read through it?
So I will confess I haven't read every word yet. I just started reading it, and I scanned through the rest. But yeah, just to balance that, it is quite long. It's not that long. It's not like a novel. I'd say it's more like a pamphlet. But what you get for that is really two things. So double the reward. You get a nice juicy rant from John Heed-Meneed, written in a way that only he can do.
Yeah, that's true.
Then at the same time, you get this collection of very diverse examples of ABI compatibility issues, many of which are quite surprising. So exactly as you said, and that will really give you a much better idea of what the problem actually is and why we need to do something about it, even if it doesn't actually tell you what we can do about it. So I think it's very valuable on both those fronts. So yeah, having the two together makes it very readable. I will definitely finish reading it when I get a little bit more time.
Yeah, we know, after the CppCon.
Yeah, maybe.
Yeah, okay.
Okay, so roundup of the standards news. Now, we actually had another plenary. Now, this is the September edition of No Diagnostic Required, but because we started pushing the recording back to the beginning of the following month, and we're now into October, we had the advantage of being able to take account of the October plenary session. So the plenary is the meeting that the Standards Committee has 3 times a year, usually associated with the physical meeting, where everyone gets together and actually votes on the straw polls for what's actually going to get adopted into the next standard. And this time we had quite a few things that were up for the vote, and there's a bit of discussion about some of them, but everything got voted in, so that was good. One of them was one that we've talked about quite a few times on this show in the past, the monadic operations for stood optional. Not going to go into that again now, just that it's a way of composing functionality on optionals. So we have talked about it several times in the past, and that's now been adopted into the working draft for C++23. So unless anything drastic changes, we will see that in C++23. So I think that's great news. Then another one that we have talked about fairly recently that got in was the multidimensional subscript operator. So this is the one where in C++20 we deprecated the use of the comma operator inside the square brackets for subscripting into an array, so that we could pave the way for, in the future, allowing multidimensional subscripting. And we were quite surprised when this paper came up not that long ago, actually, to say, well, let's get it into C++23. And now here it is in C++23. So from deprecating the comma operator in C++20 to actually getting this in, I think was a pretty fast turnaround. So I'm quite impressed with that. Another one we talked about recently was zip for sort of merging 2 ranges together. Again, we talked about that a little while ago. That's now in as well. And one other one, which I thought we had talked about, but actually I went back through previous shows and I couldn't find mention of this. So I'll talk a little bit more about it now. And that's deducing this. So I think this is actually a really important paper. I'm really glad that this has got in. So I think it's going to fundamentally change, not necessarily all the code you write, but in the places where this comes up, it can really make a huge difference. So just to sketch in the motivating problem, we have member functions on classes that often we need to annotate things like constant and volatile and reference types and R-value reference types. And if we want to write particularly library code properly, we'll often find that we have to not only duplicate code, but we can actually use this term quadruplication, because you have to write it out 4 times for all the different combinations of things. And very often it's pretty much identical implementation each time. So you can sort of use delegation patterns or use a helper function, but you'll still have to write out the signatures all those times and all the forwarding. And it's tedious. It's lots of things that can go wrong, even if it's not technically hard. Nobody wants to write code like this, and yet to write it properly, we really should do. So the example given in the paper is actually from stood optional again, or a reference implementation of it. So yeah, the standard library has to deal with this. So the idea is that this all comes about because the this pointer is an implicit parameter to your member function. So we don't get to say anything about it. It's all done for you. The const-ness, and whether it's a reference or an R-value reference, it is all a property of the member function itself. But if you were to, well, for example, if you have a like a static helper function, as in the third column example at the bottom, then you can use the template argument to actually deduce those value categories and other properties of the what was this pointer. And then you just got a single implementation. It'd be nice if we can actually make this explicit and then make it a template parameter, and then we wouldn't have to write all those forwarding member functions in the first place. And so that's exactly what deducing this proposes. And so here is the same example written using the deducing this syntax, where all you do is you declare the template, but you put the this keyword before the type that you want to refer to the this property. I forget now whether this can actually be in the non-first position. I know that they went backwards and forwards on that, but that's usually where it would be anyway. And then otherwise, it just looks like a static member function, where you just deduced the value category for this. And typically, you're going to make that a reference to an R value reference, or a forwarding reference, as in this case. And then you don't have to write all of those overloads, and you can use stood forward if you do need to do anything else with it. That's the motivating case, just reducing that quadruplication. But once you've got this, it starts to open up all sorts of other possibilities. And some of the ones from the paper are, well, you can pass this by value. So you call it member function, and rather than having a this pointer, which implies an indirection that you may not actually need to pay for, I mean, think of things like string view. Well, all you've got is just a pointer and a size. Accessing those for another pointer, assuming it's not optimized out, just adds overhead that you don't actually need. So if you can use an explicit this argument to pass it in by value, then you can save that overhead and make the code cleaner at the same time. You can also do something like CRTP, the curiously recurring template pattern, but without the C, R, or even the T, as the title says. So much more succinctly, as the example here shows. And in fact, at the bottom it actually says the proposed examples aren't much shorter, but they're certainly simpler by comparison. If you've ever done CRTP, you know how intrusive and ugly that gets. So having a much cleaner way to do it that just drops out of this new syntax is really welcome. And then one more example from the paper, recursive lambdas, because you can do the same thing with lambdas. Lambdas do have a this, an implicit this argument. Now you can make that explicit as well for lambdas, and that means you can actually call yourself back on the same lambda, which is something you can't do today, and there's been discussion about different ways that we could do that. Now we get it with this feature. There's a number of other consequences as well. I won't go into all of them. Read the paper, because I think this is a really big addition to C++ 23. I'm really pleased that it's got in. Do you have any thoughts on that one, Anastasia?
Yeah, I'm actually just looking at the recursive lambdas here, and I have to admit that the example actually looks impressive to me because it reads, like a text. So I'm just reading the code as a text, and that's so much. I guess, it's fantastic. I mean, I can read C++ as just a pure text, which is a very surprising thing to me. So the syntax is cool. I'm just thinking about, if we get in too much power with that. So yeah, probably there are some examples where maybe I don't want this power, but let's see how it goes. For now, what I see really looks impressive. I mean, it makes the code much more readable. That's true. I definitely agree. That's an interesting direction. I mean, if at one point of time we get this kind of C++ code, which will look like a pure text, so you can just read it through, but it will still be the code. And I like the direction, at least for now. So let's see how it goes in the actual, practical examples, in the practical usage in the real life.
Yeah, any new feature can be abused, but in this case, I am hopeful because what we're actually doing here is just making something that was implicit explicit. And really that's all there is to it. And that's, in a way, that's actually simplifying things because we're making the implicit explicit. It's even like in the Zen of Python that's why Python has an explicit self parameter for the same reason. This is opt-in this case, but the fact that it opens up all these additional possibilities beyond the original motivating case, I think is a strong indicator that this is just a valuable simplifying feature. that shouldn't be open to too much abuse. Where it could be open to abuse is actually building other things on top of it. There was discussion early on of extending it to doing things like something similar to uniform function call syntax, or something similar, which could have derailed the whole thing, so that was quickly pulled out. There's other things that you can do that haven't been proposed, but the core feature itself is just a really nice, simple addition to the language, which opens up many possibilities, and I think that's a really good sign.
Yeah, that's true. That's true.
Now, one of the authors of that proposal was Gashper Asman, who was also one of the authors of the minimal contract support paper that we've been talking about recently. That's had another revision this month. Not that much interesting in the revision. It's mostly sort of reorganizing the wording, making things clearer. All good stuff, but nothing too much to talk about. But as part of the ongoing discussion about this paper, there have been a few concerns about particularly the syntax, how it might be locking in certain things, particularly because we are trying to keep a minimal set of features here as part of the minimal support. And there's some concern that that's going to lock us into when we want to extend that in the future. And I don't want to go too much into it because I have seen a proposal that hasn't actually been published yet, which does propose an alternate syntax that does go to address some of those concerns. And it's interesting because it uses Lambda's captures list syntax to make, again, give an explicit way to describe how you capture, whether you copy the certain parameters, thinking particularly of post conditions, where the post condition is specified up front, but will actually execute at the end of a function. So should it have the original value that was passed in, or the possibly mutated value that was at the end? And most of the time, you would probably want the value that was passed in, you're specifying a post condition, but that implies then you've got to copy it. And there's all sorts of intricacies to that, where you don't want it to be happening automatically. So having a way to make that explicit in a syntax that's very familiar already, that everyone understands, I think is a really interesting direction. So when that paper is actually published, maybe we'll talk more about it. But I just wanted to mention it in that context because I think it's an interesting direction that we could be going in there. The only downside to this is it could be stirring up enough discussion that it may actually set this back to not making it into C++23 after all. That would be a shame, but I think also would be probably for good reason that, we're still not quite in consensus on even this minimal subset of features yet. We'll see. We've just about got time in the next few months to lock down that design. I think the February meeting is when that finally gets locked. But do you have any thoughts on that, Anastasia?
Yeah, actually, that was exactly I was thinking about when you started talking about some other syntax and all these variations, because you started the language news today with so many nice things which are kind of accepted to C++23. And with contracts, we are again on this stage of discussing variations. Which are good, but yeah, would be also good to get some contracts finally in the language. But yeah, let's see. We still have some time, so maybe we can get at least something. So we already have this kind of cut version. I mean, the contracts which were originally discussed for C++20, they're much more different from what we have now. So it would be good to have at least this MVP, good name for the language. Kind of some product management term here. But that's the whole goal. When you have an MVP, you're trying to get at least something to your customers. So it would be good to have at least something in the language. Maybe with this new syntax. Let's see when the new paper is there.
Yeah. And even ABI came up in this new proposal.
Is there any paper right now which is not mentioned in the ABI? I'm just like,
Well, the reason it came up here is because we are talking about an MVP, a minimum viable product or proposal here. As I say, one of the concerns is, how can we evolve this in the future while maintaining that backwards compatibility? And the suggestion is that if we use this closures syntax, even if we don't fully use all of the features, for example, dictating how a post condition can refer to an initial or a later value, even if we don't actually specify that now, because you can build on that lambda syntax, and we already have that implemented, that's unlikely to change as we specify it further. That was the thinking behind it. Not everyone has bought into that, so we'll see where it goes. But yeah, it's an interesting idea that we can use an existing feature to make our ABI a little bit more robust, but may not play out that way in practice.
Yeah, actually, I think John Hinman was actually discussing that in this long article, that how could you actually break the ABI with something which does not exist, but you actually can, because when you first introduce it, you have to be very careful about it, because you might introduce it in the way that to change it later, you will have to break the ABI. Yep. So that's a very tough topic. Like, yeah, indeed, breaking the ABI with something which we don't have in the language is also possible.
Yeah. Anyway, we have more views. Now, this proposal, P2415, the R1 here, what is a view, was actually published the previous month, so August, and R1 was in July, but we didn't discuss those then. And they came up again this month because the authors have done some slides to present to the committee, basically covering the same material again. So it's all fresh again, but also because it's an interesting paper that we hadn't discussed before. And the problem is to do with how views have been defined in an abstract way, as being either cheaply copyable or move only. But if they are move only, or in either case, their destructors need to be O1. So really, they basically rules out them being owning, that they can't own any of the data, because then the destructor would be more expensive. And this paper is just really questioning what the actual reasoning behind that is. Have we actually missed something here? And the motivating example that I sort of pieced together from bits of the paper, not quite how it's presented there, but if you start off, say, with a vector of ints, and you just want to call a function that returns that vector of ints, if you use that directly, it will be an R value. So that was going to go away anyway. So this could potentially be moved. If you want to then pass that to some view range adapters, then what you'd have to do is make that into an L value by capturing it as a variable. So it's moved into that, and then you apply the views to it. That all fulfills what we currently have as views in C++20. But it means now you've had to bring this, what was an R value, into the L value world and give it a name and have it around for a while. And there's a number of implications to that, which I've gone into in the paper, which make this not quite what you would want, but it's sort of what we have to do at the moment. What you really want to do is something more like the second example. It uses this bad view 2 type that's all explained in the paper. It's bad according to the current definition because it actually takes ownership of the vector that's moved into it. So you pass it the vector, it moves into this view, and then applies the transformations. And at the end, the view itself is responsible for cleaning up that vector. So it has that more expensive destructor. But it was a cost you were going to pay anyway, whether you pay it externally in the vector that you've taken a copy of, or internally to the view. shouldn't really make a difference. And the argument is that this is a cleaner way to do it, and also gets us perhaps closer to being able to treat containers themselves as views, because now views can be potentially owning as long as you've moved their contents in rather than taking a copy. It's a little bit subtle to get your head around, and I may not have described that perfectly. But it's an interesting problem, because you would think of views as never being owning. And in fact, that's really what the current standard wording implies. So it's an interesting diversion from that. And interestingly, this proposal actually also got voted in to C++ 23 this week. So although there was a bit of discussion about it, it wasn't enough to stop that from going in. So it looks like we're going to see owning views in C++ 23. Do you have any thoughts on that?
Not that many, actually. I'm just thinking that even the owning views got their green light to the standard. I keep thinking about the contracts here. But yeah, that's probably a good change and not a very, dangerous one. So looks okay.
Yeah, I think there are some dangers there, but I'm not intimate enough with it to be able to describe them now. But if you're interested, I do recommend you read the paper and draw your own conclusions, but maybe too late to actually change the vote at this point. Okay, so let's have a look at the tools news for this month, starting with Visual C++ getting C++ 20 support officially. You want to talk to us about this one?
Yeah, actually, it caught my eye because it was actually mentioned in the John Hedman this ABI long read regarding the no unique address. But in general, there is this announcement that Microsoft actually announced the sufficient level of C++ 20 support in Microsoft MSVC compiler, and they even added this to the C++ 20 switch. Which means a lot, because you probably know that the way they maintain the ABI compatibility is that they are not stating the ABI compatibility for this C++ latest switch. But with this C++ 20 to C++ 20 switch, that means that, they do consider it quite stable in terms of the ABI. So that's actually indeed a huge announcement, and a huge point in time. And we're here on ABI topic again. So I will skip the biggest part of this announcement and we'll come to this point of no unique address. So the problem is that the Microsoft compiler kind of ignores the attributes that it doesn't know, and because it's actually allowed by the standards. So, and that means that the C++ 20 no unique address is kind of causing the issues for the code compiled with the Microsoft compiler. So you can get the problems when, as listed here, you have compiling this the same header source under different switchers, or you're linking some libraries built with older versions of Microsoft compiler. So you might get into the ABI issues here. So to avoid that, Microsoft actually did a very interesting thing. They decided to postpone the optimization for this new C++ 20 attribute until the next ABI package in the MSVC. But if you still want to force the optimization, there is another attribute actually introduced, which is called MSVC no unique address. Kind of very similar one, but very specific to Microsoft compiler. And it works in versions of Visual Studio 2019 and higher for all compiler switches, whatever. So if you still want to use the feature, you can do that, but you have to switch to this very compiler specific attribute from the one from the standard. The one from the standard is actually kind of not working as it should be until the next ABI package. And that's a very interesting approach, I would say. Just introduce a new attribute if you still want to use it. So you're probably doing it kind of more explicitly and thoughtfully when changing the kind of generic attribute to a compiler specific one. So that's the story mentioned in the ABI long read. And also, maybe the most important and interesting point in this announcement, apart from the fact itself that Microsoft confirmed the sufficient level of C++20 support. What do you think about this attribute switch?
Well, I'm not going to go over the ABI story again, but what I found interesting about this is the fact that it was the introduction of the attribute that caused the ABI breakage, or rather the change from whether you do anything with the attribute or not. Because there's a common narrative that attributes shouldn't change anything whether you have them there or not. They're just there to annotate something or give a hint to the compiler whether it's going to warn you about something. Think of something like no discard, for example, rather than actually changing what the compiler is going to generate. This has come up. We talked previously about the contract syntax, which looks like attributes. It's not even attributes, but because it looks like attributes, people are saying, yeah, but we can't then let that change the code that's going to be generated to introduce these contracts. That's one of the problems with the syntax. Whereas this is saying, well, if you use this attribute, it's actually going to change the layout of the object in memory, and therefore can potentially cause an ABI break. So, yeah, I think that horse has already bolted. So maybe we should stop talking about attributes not changing what gets compiled.
Yeah, I don't think that no unique address attribute had any chance to avoid that. Nope. I mean, like, it was specifically introduced to do that and to change the object layout. So yeah, no chances here.
Yeah. The ABI side of it is quite sad though, but hopefully one day we'll get it sorted. Okay, yeah. More positive news then.
Yeah, definitely not about the ABI. I do hope so. So yeah, we've started the early access previews for 0.3 versions for our C++ tools here in JetBrains. So CLion is the first one to talk about. So actually, this time the team is kind of focusing on, enhancing the debugger experience and making the better embedded development experience, and also making the toolchain and environment configurations much easier in CLion, which is still kind of a problem for some of our users, and we do hope to improve in this direction. So regarding the debugger, like, there is some refreshed UI and like some new views in the debugger tool window, like we added the Perl stack view, and also some new tabs for FreeRTOS case for those who are working with it. And talking about the embedded development, there are some improvements to peripheral view and hex view in the debugger tool window. And talking about the toolchain, what we actually done so far is that we actually bundled MinGW for Windows. So if you're on Windows, you can just, download CLion, and the MinGW toolchain will be already there. So you don't have to download these packages and trying to, figure out which parts to install. You no longer need that. And also there is we switched the default generator in CMake and CLion to Ninja. And I guess that's the right choice for now, because Ninja is much more popular, I guess, and better in terms of the performance, because previously we were using the Makefile generator. So the switch is done for CMake 3.20 and higher versions. And also we actually bundled the Ninja so that you even don't need to, to download and install it. So the bundled version will be used in many cases. And the next part of this toolchain story is that we added an ability to configure the environment by sourcing a script, which is a very popular case in various embedded toolchains and like many others, when you just source a script to set the whole environment. Previously, you still can do, there was an option to do that. You can pass the environment to the CMake options, but it's kind of inconvenient, especially because usually you have this script, so you just need to launch it properly. And now you have an option to pass it to CLion, to toolchain, and CLion will be sourcing the script in a proper points of time. And yeah, from the point of readability of the code in CLion, probably the next big thing we added was this type hints, which appeared. And previously we had these parameter hints, and now we added the type hints, and they actually make the code much more readable, especially for like these auto variables or structured bindings or even lambda return types. So you can have these types now in the editor and look at what actually is happening there, like in this case with the deduced types. And I actually even have one teaser because it's not yet in the public build of CLion AAP, but I do hope that maybe by the time the episode is live, there will be a build available for everyone, that the Docker toolchain is actually also coming to CLion. So that's to the point of the simplifying the configuration steps. So there will be a dedicated Docker toolchain. And if you were using Docker in CLion, so previously we were recommending you to use the remote toolchain and to work with Docker like with just the remote machine. But there were some issues with that it caused the redundant source synchronization, because you actually don't need that. So now with the Docker toolchain, there is just the project folder is just simply mounted to the Docker container. And so there are no like code duplication or redundant synchronization done. So it's much lighter in that case. So this new Docker toolchain will be coming next to the CLion AP. So yeah, and I guess that's the biggest thing we have for now. And I hope more are actually coming. The actual release is planned in the end of November or beginning of December, as usual. Yeah, and the next tool in the family is ReSharper C++, and we also started the AP for this product. So like ReSharper and its sibling ReSharper C++ are now both available for Visual Studio 2022 preview. And that's actually a very big news, because Visual Studio 2022 is finally allowing 64-bit processes for including the extensions, and which actually gives the plugins more memory and improves, overall performance and responsiveness in the large solutions.
Can I just emphasize the word finally there?
Yeah, finally. Like the preview builds are available. So we started actually some very closed preview in summer, and now it's available in the regular AAP builds. And it seems that it's working nicely. So it indeed addresses quite many issues, which were mostly caused by the lack of the memory, because 32-bit processes and C++ are kind of tough altogether.
Mm-hmm.
So yeah, it makes things much better. And on the more product-specific improvements ReSharper C++ has in this AAP, it's actually trying to force recent C++ language changes and best practices on users. So like the new standard library functions, which are actively promoted, and some best practices are suggested via the new code inspections. So you can find a few very interesting cases there. And also to the similar question, to the similar topic of the code readability, like we have the type hints in CLion, we already have them in ReSharper C++, but this time for better readability and understanding the code easier, in this AP we actually updated the quick info tooltip to include the evaluation result of the constant expression. So you can now see the actual result, the actual evaluation of this constant expression in the quick info tooltip. So which probably makes the code a bit more readable as well. So yeah, this is also the nice change there. And yeah, that's mostly it about these two AP programs started. So do you have any thoughts on that, Phil? Any comments?
Actually, just going back for a moment to the CLion release, or EAP, and the type hints feature. As you said, that sort of follows on from parameter hints that was out a while ago. This is one of those features that I both love and hate. And so I actually have a feature request associated with this, which is it'd be really nice to be able to quickly switch that feature on and off. Because when you want it, it's really handy. When you don't want it, it's really annoying, because it can actually change the how much you've got on the screen at once.
Yeah,
I did actually try.
You can actually do that. So if you just right click on the type hint, there will be like a context menu where you can just turn everything off, or just open the settings and some there you can do some configuration there. Like, for example, if you prefer only the parameter hints or some very specific type hints, you can do that from the context menu. So maybe not the one click, but kind of, a click and then some action.
Yeah, and I did try creating a keyboard shortcut for the globally on and off, but I found that it didn't actually take effect until you restarted. So that wasn't so useful. But yeah, it'd be nice if that could be done globally. But apart from that, it is a really nice feature.
Yeah, definitely we can consider that. I guess we have something like that in ReSharper C++ when there is this push to hint option where you can actually avoid these hints, but you can press some magic buttons to get these hints on the screen. So it's possible there. So maybe we have to consider something similar in CLion as well.
Yeah, no, that'd be good. So talking of CLion, I'll let you take this one.
Yeah, I can actually take this one, even though it's kind of written by you, Phil. But thanks for the nice article. I have to admit here that I really love that. So that's about the SonarLint plugin for CLion. And actually, following our developer ecosystem survey results, we can see that most of the people, they do rely on their IDE capabilities in terms of the static analysis, which in case of CLion are quite wide, but as usual, you always can do more, especially in terms of the static analysis, and especially for C++, I guess there are lots of possibilities here. And so for sure, there are plugins enhancing the building opportunities in CLion, and SonarLint plugin is, it was released, I guess, somewhere in the beginning of summer. I don't remember the exact timing. Yeah, and so this blog post, kind of explains the benefits which the plugins bring to the users. So there are a few examples in the blog, so you can read through and see how the checks from the SonarLint plugin are enhancing the building functionality. Like, for example, do more details for the bundled const-ness checks, which is for sure are useful, but sometimes they're quite general. I mean, you can do much more with more specific details, and that's what the SonarLint plugin suggests. But what I found really very interesting is these security issues and how you can address them with the SonarLint plugin. Like this case with the which I found personally very interesting, is the compiler which might optimize out the code to memset, which might clear the passwords in the memory. And the way to how the plugin suggests to change it to memset as called to fix the case actually. And this also these checks regarding these cryptography libraries in your code, which might be when you might call some outdated algorithms, and how the plugin suggests to use something better in this case. So I think these are the nice additions. And I found personally very interesting examples in the blog post. So thank you very much, Phil, for that. So especially for the clang-tidy checks. I have to say, clang-tidy is a great tool, and it's good to have something like this basis in the community when you have all these basic checks available to everyone, because quite many tools are right now bundling the clang-tidy. And so you get them just out of the box in your IDE of choice. It might be CLion or it might be some different IDE. So you have them, and that's great. But we always can do more, and we always can do more checks here. So I don't know, Phil, what's your favorite check here? What's your favorite case from the blog post?
Yeah, that's a good question. I did particularly like, I don't have it on the screen, but the very first example, which does exist as a clang-tidy check already, to check whether the argument you're passing by, I think it's only by pointer in the clang-tidy case, if it could be made const if it's not actually mutated. And we just extend that to more types and to the references as well, and a few other things as well, just to make it more rounded out. But that's something that I would find really useful, particularly if I'm working with a legacy code base, to find places that you can make that change.
Yeah, that's exactly what I call the basis you have in a clang-tidy, but then you kind of extend it with some more types, for example, or some more cases, like which goes, beyond. So yeah, in that sense, it might be a very interesting experience. So yeah, do try the plugin. It's kind of available in the plugin wrapper. So, and it's free, so you can just download it, install into your CLion, and try it out. And yeah, you can report some feedback to Phil
Yeah,
or to us as well.
It was an interesting article to write, sort of having worked on both sides of it.
Yeah, but you kind of, knew the topic, which is good.
You would hope, yeah. Okay, so finally, then, CppCon. Is that going to be on this year?
Yeah, actually, it's a good feeling to wrap up with the conference topic in the current times. So yeah, finally, CppCon gonna be a hybrid conference later in October. So I guess our next edition will be after the CppCon. So we'll probably share our experience after the CppCon edition this year. So it actually announced the program, and I have to say that it's going to be, as I said, it's going to be hybrid. So there are like 4 tracks planned for on-site attendees and 5 tracks for online attendees. So I really would like to be there in person in Aurora, in Colorado, but I won't. I will be only online. But the program is great. I mean, like, you can actually, it's nice to see that the program now have it has all these marks like online or just on-site talk or both, which is interesting to inspect. And also there are quite interesting tracks available this year. There is this classical back to basics embedded track and also a new software design track, which I find very interesting. And there are like great talks announced there and great keynotes. Like I would definitely suggest you pay attention to a few of them. And the tickets for the online are still available, and it's so easy, to just buy an online ticket right now and to join the CppCon like the next day, which is super easy thing. You don't have to fly anywhere to to book the hotel or the travel or to think about if you're actually capable of getting there. So just buy an online ticket and join the great event. And there will be Bjarne talking about the general goals of C++ and how we're achieving them through the times, which I personally find a very encouraging keynotes. I hope they will be great, and pretty much sure they will be actually. So, and he's going to talk about many interesting things. And I found a very interesting point in the talk announcement that the announcement is mentioning the elimination of the preprocessor. So it would be interesting to hear the Bjarne's word on that. Titus Winder from Google will be teaching you how to do the design for the long term, which I think is a perfect topic for the person from Google. I mean, who could talk about the designing huge systems for long term if that's not Google? And yet, hope for the great talk from Titus. Herb will be talking about the pattern matching. I like the way he's, promoting these new proposals to the audience. So we'll see what he's going to talk about in this pattern matching talk. I also like the Jason's talk announcement regarding the const-expert and giving some practical applications for const-expert. I think this all these talks from this const-expert, all the things, or not const-expert, all the things, and all these talks from this series, I think I will love Jason's talk as well. Michael Chase with some talk on embedded and many other talks there in the program. So the program is really great, I think. And I guess both of us will also have a talk there.
Yep, I'll be delivering it remotely as well.
Yeah, unfortunately, or fortunately, I don't know. I would like to give it in person, but I will be unfortunately giving online. It will be code analysis plus from me, and I guess a talk dedicated to code analysis as well from you.
It's slightly more general than that, more about software quality, including static analysis. And it's Zen and the Art of Code Lifecycle Management, think I got that right.
I like the name.
Yep, you have to see how I connect that all up when I come to the talk.
Yeah, that sounds great. So yeah, both of our sessions will be online. And yeah, we'll be capturing various aspects of the code quality, I guess. But there are actually a few other conferences around. Like, for example, today we have finalized the program for C++ Russia conference, which will be in the middle of November. So we'll soon be announcing the final program for C++ Russia. So do you know any other news from other conferences?
So I'm actually going to, in person, NDC Tech Town in a couple of weeks. That's in Norway. That'll be the first one back in person that I'll have been to. Obviously, I can't go to CppCon this year. The visa situation hasn't worked out for travel from the UK. But then shortly after that, there will be ADC, the Audio Developers Conference in London. That's going to be a hybrid as well, so an in-person component. I may get along for a little bit of that. C++ Russia, as you say, and Meeting C++, I think that's also in November, is going to be purely online this year again. And then CppP, the Paris, no, normally in Paris. I say normally, it's only been there once so far, but that's going to be purely online this year. It was cancelled last year completely, so good to see that back. And not quite so relevant to the C++ crowd these days. It used to be a bit more. NDC Oslo is also going to be in person this year. That's also in November. I'm going to be going along to that one. So yeah, a good mix coming up of online, in person, and a couple of hybrids. It's going to be interesting to see how they work out. It's really our first attempt in our community, at least, to run these hybrid conferences. So yeah, keen to see how they're going to work out.
Yeah, that looks impressive. I actually recently read for the kind of trip report regarding the Core C++ conference, which was held in Israel in August, I guess. So it was kind of in person, more or less local conference. I mean, like most of the people there who were present there were from Israel itself. But there were some, I guess, speakers from other countries, I think. But yeah, I've heard that it was quite good and it was like a very nice event, not that small one you could think about. So kind of a great event there are quite many great developers there and there are lots of interesting topics they were discussing. So yeah, it seems that it was great. So C++ Russia, we were actually thinking about the hybrid conference maybe 4 or 5 months ago. But it turned out that it's not feasible right now, so we converted to pure online just, to do preparations in a proper way. I mean, like when you're not thinking about what is possible and what is not, but you're just preparing the conference. So, we do have a great lineup right now. Hopefully we'll be publishing the program soon with talks like both in English and in Russian. So I do hope for a great Russian event there. And probably we might be back to some offsite events for my user group, maybe in a couple of months. We're right now discussing a few options. So we might try to set something up. So as you know, probably that I put it on hold because I feared that I don't have strength enough to to go to online, maybe too tired of all these online events. So I decided just to put it on hold. But right now, I think maybe we will restart slowly in this kind of in-person mode. We'll see how it goes.
Yeah, I'm looking at doing similar with C++ London, but as we get into the autumn conference season, I'm actually finding very little time to organise it. But
yeah, it's pretty much packed, I would say.
Yeah.
Even for the pandemic times.
In fact, I'm going to CppP, the normally Paris conference, which is December the 1st to the 3rd, and also NDC Oslo, which is also from the 1st to the 3rd. I'm going to be in Oslo in person and also attending the conference in Paris remotely.
Yeah, but these are the benefits, of this
exactly.
modern world of online conferences. So yeah, that's true.
Okay, well, I think that's well over time for this month, so we should definitely wrap up there. But we will be back within a month, hopefully, to give you another packed schedule. So we'll see you all then.
Yeah, see you. Bye.